I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with the leaders and innovators to make it all happen. On today's episode, we're absolutely honored to be joined by Aaron Wells, Director of Engineering, Blue River Technology, a John Deere company. On today's episode, we'll discuss autonomy, precision ag, and how Deere is planting the seeds for autonomous farming. We hope you enjoy this episode. Aaron, welcome to the podcast.
Hey, thanks for having me, Grayson. It's great to be here.
It's great to have you here. I'll just say point blank, Blue River builds cool technologies.
Hey, thanks. Always nice to have a fan. Always nice to have a fan in the autonomy space too. We're excited about the products that we build, and excited to share more details and be able to pop the hood, talk about the technology a little bit.
Yeah, because it's awesome. Blue River's a part of John Deere, and we were saying earlier, nothing runs like a Deere autonomously. That's the key there. How is Deere approaching the future of farming? Because I've noticed over the last 3 to 4 years, Deere has gotten very public from a messaging standpoint around their embracement of automation and autonomy and the benefits it's going to have for not just family farmers, but also your traditional larger farmers.
Yeah. How do you think about the future of farming? And I've thought a lot about this recently. And actually, I think that the way that we approach the future to farming, or maybe the method that we use to think about the future to farming, actually hasn't changed that much. So if you think about quick history, right? If you think about John Deere, like the original John Deere, the founder, the man, right? Like the system he used was, hey, he went out to a field, he looked at customers, he looked at farmers, and he asked questions, what are your challenges, right? Make some observations. Where are the struggles in the production process today? And then he went back and he used the tools and technology available to him at the time, right? To go make a difference in that industry, to go make a difference for farmers. And the truth is we're doing the same thing today. So what happens is when we go to the field, like John Deere did, when we spend time in the same boots and the same mud, the things that our customers tell us are the hardest part, the hardest thing that we're struggling with today. It's not tilling the soil like it was, over 100 years ago. The thing we're struggling with is labor availability, right? John Deere's been in the tractor business now for over 100 years. And it turns out, 2025, the hardest part on a tractor, maybe, or the hardest part to fill is the operator seat, right? And that's where autonomy comes in.
The labor shortage, and this has been well reported, is that it leads to families losing the farm because they can't get anybody to work it, which is sad. And then automation can allow them to keep the family farm and pass it down to multiple generations. How much of an impact is the labor shortage having on Deere's automation strategy and plans?
Sure. Yeah. So, if you think about the journey that John Deere has been on, right? We've been on this automation journey, this automation to autonomy journey for 20 plus years, and really where it started was, how can we think about doing the job more precisely, taking some of the load off the operator, building a better, stronger, faster, more productive machine for the field. And on the technology side, what that looked like in the 20 years ago now was AutoTrack, right? The ability to self-steer through a field, to plant really tight rows and to plant them very accurately, to get the most out of that ground and that cropland. And that journey today, right, has enabled us to build things like perception systems on top of that, to enable that with eyes and AI to sort of complete the picture, to enable that tractor to operate without a human inside. So just some tidbits of where this is really important in agriculture. If we zoom in on California specifically, it's a really vibrant area of the agricultural economy. Coming from the Midwest, when I think farming, I think, soybean fields, corn fields. I could probably open up my window and show you one, right? We won't do it, but I'm very close to that production system. In California, what that looks like is it's very similar to sort of walking into a grocery store. And that first view you get, it's very colorful, right? You have your citruses, your lemons, your limes, your oranges, your avocados, right? Those are all grown on trees in California. And about 50% of the folks needed to drive tractors through those trees, we can't fill those seats today, right? Is what our operators tell us. So, the ability to do a job with the equipment that you have without facing this labor shortage in some areas is really impactful, right? For farms of all sizes.
But the sad part, the reality is in California, you can't legally operate there because the Cal OSHA regulations. And that's a big issue. How do you overcome that issue, or how does the farming community overcome that? Because I keep going back to the family farms, and a lot of these are multi-generations, and they want to keep the farm in the family, but without automation, they can't pass it on to their grandkids or to their great-grandkids.
Sure. As we think about when we first launched, the autonomy effort, we've been on this for 7+ years now, specific to perception. One thing that we said early on is what makes a great safe, product is obviously safety first and great transparency. So the way that we, work with these entities, Kalosh is a great example, is a partnership mentality, right? Like, we have a job to do in industry of educating what safety, best practices could look like using technology that we have available today. And having that conversation of, hey, we are both in the business of keeping our customers, operators, farmers safe, right? Like that's an incredible part of all of these products, and we could do a lot, right? We can do a lot in that space to keep our customers and farmers safe. So let's have the conversation, and I think that's been successful, especially over the last 6 to 8 months of opening up some dialogue to see what we could do to alleviate some of these concerns.
There's a lot of safety issues on farms. How much does the safety message resonate? Because you're going to increase the efficiency of the farms, you're going to do really good for society, but the safety implications are going to go up. Is that messaging resonating?
Yeah, I think so, right? So, I mean, I'll say that, safety is I like to say that safety is the first and last conversation and half of the ones in between as we develop our products and features, right? Like safety is core to everything that we do. And on top of that, you're exactly right. So as we think about if the operator isn't in the seat, what kinds of things can they go do, right? And there's a lot. If you think about autonomy, it really isn't about the tractor driving itself. It's the farmer focusing on what only a human can do, right? That's really the core value proposition that we're bringing today. So whether that's just optimized time management, running the business, monitoring your crops, scouting crops, spending time, with your agronomist, making a plan for, how to best, plant and care for those crops, that's time better used than some of these monotonous jobs. Great example, again, zooming in on California. It takes, for some of these operations, maybe I'll use spraying as an example. This is something that's done 7 times a year at 2.5 miles an hour, right? So for 10 hours a day, 2.5 miles an hour all season long, that's a pretty tough job to try to do to bring that crop or that tree to a state that gets it to full production, right? So enabling those folks to better use their time is certainly part of the solution. Another, maybe story that goes along with this, we met a farmer in the Plains area, and he says, hey, I just want to look after my cows, right? Like my time is best spent, with my cows. The thing actually that brings me joy is spending time with the cattle, tending to the herd. And he was saying this while he was in a tractor doing tillage, right? So another example of that's not the most valuable place he could have been that day. How could we enable technology to get him to that most valuable place?
Are you finding your customers, the farmers, are openly embracing automation and wanting to deploy it on their farms? Or is there still some of that hesitancy there is in other aspects of automation and autonomy?
Sure. I think there's a couple things that we've seen over the years. One is, I'll go back to the AutoTrack example. This is something that was very new 20 years ago. And again, it's the idea here is the tractor, drives itself down the rows using very accurate GPS. And it does a more precise job. And it also takes off some of the workload of the operator by making sure everything is lined up perfectly. And at the time, it was uncertain how many folks would really adopt this technology, how widespread its usage would be. And today, I would say it's ubiquitous across many farms, across almost all large farms, certainly within the United States. It becomes almost the background feature of a tractor, a lot like the radio of a car is today, right? Like it's just something that's so integrated with the production system of how you farm that it almost fades into the background. So, as we move on to these new technologies, autonomy being an example, we're thinking about the same ways to lower that adoption boundary. One way that we can think about that, and one thing that customers have told us is really important is, hey, meet me where I'm at today in my automation journey. So if I have a tractor today, by and large, can we retrofit a solution to take that from a highly automated vehicle to an autonomous vehicle? Can we take maybe some of the same tools the farmer is using today and make those autonomous with really minimal adds that the farmer would be responsible for? So that really helps in that adoption barrier. Is instead of looking out for maybe a new autonomous tractor, we take that tractor and make it autonomous, right? And that enables a little bit of an easier flow through for customers to get into this new tech stack.
Oh, that's wild. So let's say I'm Farmer Grace and I have a Deere tractor. There's a upgrade path or a retrofit path for me to send it to the dealer or to have a Deere representative come to the farm and retrofit it?
Yeah, a couple examples, right? So on the larger tractor side, model year 25 and newer will leave the factory something that we call autonomy ready. So that means all the harnesses and controllers are ready for you to mount the cameras and go, do an autonomous operation. All the way back to model year 22, we're looking at retrofitting those vehicles to bring them up to autonomous capabilities. And then the same thing with the tillage and tools you use today. So no special tools required. If you're using a particular sprayer in an orchard or a particular tillage tool in the plains, right? Those, we're looking at the widest possible compatibility to enable you to use those tools that you already have today.
When you look at different environments, deploying in the Dakotas versus, say, Kansas or even Iowa, different soils, different weather. Let's be honest. Let's get into the weather.
Yeah.
I've been caught in hailstorms out there that come out of nowhere land. How do you harden the equipment for these environments that are frankly unpredictable?
Sure. Yeah, that's right. Weather is challenging for sure, right? And you're exactly right. It depends on the region that you're in. And I think what has worked really well for us in our journey here is what we do with a lot of John Deere products is involving the customer early, getting the solution into their hands as early as possible and getting that field exposure, right? Understanding what a dry spring looks like in Colorado. It's pretty dry and dusty. Understanding, what a wet summer looks like or a wet fall looks like in Minnesota. It's pretty loamy and tough to get through, right? And then on the other end of the country, right, understanding how do we, get underneath tree branches for a sprayer type application in an orchard when they're, full canopied, and GPS is really challenging. So, all of these is the earlier we can get in those customer fields, the earlier that we can partner with customers to get their feedback for them to see the solution allows us to adapt to some of those conditions.
So you have different conditions, different environments. You're right. Some are very narrow, some are wider. How do you build the automation stack for these different environments? If I'm going to ask you to build an automation stack for a car, okay, yes, it goes on the road and it has lane markings. But when you're on a farm, there's no lane markings. There's trees, there's obstacles, there's animals. How do you build a stack for these different environments?
Yeah, that's the challenge, right? Like, Grayson as the autonomy engineer, that's one of the challenges that you're dealing with day to day. So our approach is, we start with, we'll say like a base autonomy tech stack. So, we have a vision processor unit that's powered by an NVIDIA Orin that goes across all our solutions. We have very similar camera architecture that goes across all our solutions. And then, we really do a deep dive into, okay, where does this need to be successful, to your point, right? So if I'm underneath tree branches in California, that's a very unique environment, right? That doesn't look anything like the plains in the Dakotas. So what we do there is, yes, we use the same vision processing equipment. Yes, we use the same cameras, but we also add LiDARs to enable better localization in some of these GPS denied environments, such that we can, maintain ourselves going down the rows of trees and still do a really great, accurate job in that environment. If you flip over and think about an operation maybe in the Dakotas, right, then it's okay. What kind of machine learning approaches can we do to help us have great productivity in dust, right? To use a computer vision solution that is still, very, very resilient towards some of the dust that we can encounter there. That's what the process looks like is, hey, let's get out there, let's get the data, let's deeply understand the use case, and then take something off the shelf that we're developing, modify it in such a way that it's tailor-made to be successful there.
So basically you have a foundation model and then you tailor the model depending on the application that you're going to deploy it in.
So you've already solved it, right? I think you'd have a great day on the job. That's right. That's 100% of approach. Same thing with the hardware, right? Like you take kind of the maybe the foundation hardware, you can call it, kind of off the shelf, and then you fine tune the hardware approach for those jobs too, to work really well in that customer application.
Now, when you're fine tuning it, now the curiosity hat's on. So obviously Deere has, I'll call them normal size tractors. Then you have professional size tractors. And then you've got oversized construction equipment where I look like a Lego guy next to the tire. Different stacks. How do you build for those different, let's call it platform or vehicle types?
Sure. So, the first thing is deeply understanding how customers use that vehicle today. So, for the person, the Lego person next to the big dump truck approach, right? Like, hey, what do those mines look like? What kinds of obstacles and difficulties are we going to see there? What's it really important that vehicle do? Dumping accuracy, loading accuracy, things like that. So, is that going to cause us to tailor make our software or hardware? Probably a little bit of both, and make sure, that's really accounted for early in the design and then through the development process. Same thing, flip the script and think about, California. Okay, so now we're on a smaller tractor. We can't use the big one or else we're going to knock all the trees over, right? So we need to tailor make both the equipment from a hardware, from a tractor perspective, and from a computer vision perspective to work in that environment as well. And we need to get the cameras a little bit lower, for instance. So that giant dump truck, cameras being up high, is going to give you this great field of view, right? It's going to allow you to see really far and react to objects a long way away. Flip the script to the orchard application. Well, now I'm doing 2.5 miles an hour, underneath a canopy. If I put my cameras up really high, what I'm going to see is leaves, right? Because I'm going to be in the trees. So these are actual machines that are brushing past branches all day. So, contact with branches is normal. So we need to actually be able to see underneath the canopy, both from a, collision avoidance, from a safety perspective, to make sure there's no humans around, and also just to be able to safely drive without getting too close to any of the trees.
If you look at that scenario, could you achieve what you're achieving today without the breakthroughs that we've had in computer vision?
I think, the breakthroughs in computer vision and machine learning in the last, 10 years have really enabled some of this. Certainly we had, and it's both sides, right? The classification accuracy. So our models today will tell you, of course, what's a human, what's a vehicle, what's safe drivable terrain, what I might not be sure of, and I might need to pause and introspect. All of that has to happen in real time, right? Like that has to be computed frame by frame at a speed fast enough to keep the vehicle safe, depending on how fast that vehicle is going, to allow it to react to something. Now, I'm sure you talk to a lot of folks, doing the same thing over the road. One thing that is in our benefit here is, we can always stop. If we're not sure, we can always take that safe decision, bias towards safety, and stop anytime. Obviously, on the 101, right, or on a highway, I can't just stop. That's not a safe behavior, but I can do that in agriculture. So if I'm not sure I could stop, the system can introspect, can understand what's in front of it, and then make an operational decision that's always safe.
When the system stops to make a decision, does that trigger, say, if you want to use the term, the remote operator, goes back to the farmer, and the farmer either hits the green go or the red pause button or no go? Is that how that works?
Yeah. So the short answer is it depends. It's a little bit of both. So as an example, if you are traversing a row of trees and maybe the system stops for a branch on the ground, maybe the branch, we're not quite sure what it is. There's a couple different paths that could take. One is we do have teleoperations in the loop to make decisions on a frame by frame basis. And maybe this is something, hey, it's a small branch, you can continue forward. We won't even bother the customer in an instance like that, right? Like we only want to send the customer operational decisions that matter for their farm. Certainly Autonomy is in the business of giving time back. So the times that we reach out via that push notification on your phone, right? Like we want those to be very meaningful. I'm sure you have a lot of apps that send you a lot of non-meaningful notifications. That's not the experience we want, right? We want to send them, very meaningful notifications of, hey, we saw this, would you like to go around it? Would you like us to stop so you can come and collect it? What's the right thing to do here? We have seen the farmer's dog in the field in the middle of the night. We have seen cows that have escaped, and that push notification has been very meaningful, right? Like, oh, okay, no, let's stop the mission. There's something else wrong here that I need to go address. So, but at the same time, again, if it's something that the system can handle on its own, if it can go around it, if it can go through it, if it's not a risk to the implement or the tool that it's carrying, we can do that automatically without the customer in the loop.
When do we get to the point where Deere's autonomy solutions are fully autonomous, no human in the loop?
Yeah, so I think especially for this type of interaction that we're talking about, we call them false positives, right? This ability to see something in the field, to take the conservative action and pause for it. What we'd like to see is on a fleet-wide basis, obviously the models becoming more sure of themselves and needing less of this iteration. So certainly, that's part of, the fleet-wide solution. The other thing is can we do things in the cloud to make the vehicle more sure, like running deeper models, running larger models without having to actually involve a human, right? So certainly, it's a one-to-many relationship on our teleoperation side today because, the vehicles are really maybe calling us up every couple hours in some cases with one frame that we need to make an operational decision on. But as the technology improves, we see that rate going down too.
When the farming system becomes fully autonomous, and let's use a mid-sized farm, could we see that farmer or that organization that operates that farm expand the fleet from the smaller number they had today to larger because of the fully autonomous of what it unlocks for them?
Yeah, potentially. I think one way we look at John Deere looks at farming is, we support all different types of farming from where people are today to where they're trying to get to, right? So we're going to try to make a whole bunch of tools to try to address some of these pinch points in individual operations. And it's really up to that customer to decide, hey, I might have, sufficient labor for job A, but not job B. And as we expand this, list of things that these vehicles are capable of doing, does that make sense? So maybe a story along with this one too. When I first started in John Deere, many years ago, I noticed that, there's a fair amount of people taking vacation in that September, October, time frame. And that's because lots of folks have ties to a family farm, right? And they're going back to help out. They have a full-time job, but if the harvest has to come in, the harvest has to come in. And with that means fall tillage and other jobs as well. So the hard part of farming, one of the hard parts of farming, other than it's a very full-time job, is that your labor demands are very spiky. So, during the season, it might be a 10-hour day, but now during harvest, you might have 10 days to get everything done. And that's more than a 24-hour day, right? So you need to draw on additional resources during that time, family, friends, right? I think that's common for some of these operations. So, in the specific case of folks here going back and helping, great, they're in the Midwest, they can help out. Where the labor crunch really affects some operations is when they don't have those additional resources to draw on, right? Those maybe the family's not involved in farming anymore. Maybe, they're not in a place that can come back and help out. So if your tillage tractor can go do work while you're doing harvest, it makes the acres that you're covering more tenable, right? Like it makes that job be able to be done at the proper time, and it allows you to stay productive.
There's spikes that are predictable. So do we get to the point where you look at Deere, you have a culture of a lot of farmers that work inside the Deere organization? Where can we get a point where Deere does a tillage as a service or an autonomous tractor as a service with that peak demand where that autonomous tractor can fill in that backhaul that they need, and then it can go back to, say, go back to Mr. Deere's barn, and then it rolls out to the next person, so they don't have to hold that asset, because some farmers don't have the financial wherewithal to hold that asset all year round?
Yeah, I mean, I think it's nothing that we've discussed so far, something like that. The logistics of farming are hard, right? The labor availability of farming is hard as well. So if you think about maybe a mid-Iowa farm, when it's time to harvest for your friends, right? Your neighbors, that whole community hits that time at the same time. So it's not just my farm that needs all the equipment right now. It's everybody's farm, right? So that's why, for a lot of folks, it has made sense that, hey, I need the capability to get in the crop, within 10 days when that time period opens up. So certainly that's an automation standpoint. That's been a huge driver of the technology, right? How do we make you as productive as possible for that critical 10-day window? It's like the Super Bowl of farming, right? Like it happens in these short windows, same thing for planting, same thing for certain application periods. And that's what makes it so challenging to get the equipment that you need at the right place. So if you're borrowing or sharing a tractor with maybe a neighbor, right? That could be difficult if you both need it and it's going to rain tomorrow, right? That's where some of those pinch points can come in.
It's all hands on deck when you really think about it. It's just, you got to go. You bring in the robots. When a farmer first wants to deploy an autonomous Deere tractor or they want to retrofit it, Do they have to have the farm be pre-mapped, or is there any work that has to go in before the tractor can start doing its job on the farm?
Sure. So, what the workflow looks like today is you need a boundary around the field that you want to work. Largely, this is something that has, been part of our tech stack for a long time. So, we have this offboard digital cloud-based component called John Deere Operations Center. And this allows you to manage your farms and fields and also see all the different operations that you've done to your fields, see some of the yield and how that's impacted some and make great agronomic decisions, right? So the concept of having a boundary and setting up work and, making a plan ahead of time, that's largely part of some of the foundations of the tech stack already. So that's one thing that Autonomy really builds off of are some of those cloud-based components. So certainly, having a boundary around the field. Farmers are very prescriptive of how they like their farms worked. I've learned a lot about farming in the last many years too. Tillage specifically, some farmers will like to run, whatever angle the crop was grown at. Sometimes they'd like to run at maybe 3 or 4 degrees, right? Like single digits of degrees, just enough to make sure you're incorporating the residue or the additional plant matter back into the ground, for instance, right? So, establishing that work plan, for a citrus application, it would be, hey, what trees am I spraying? What's my application rate? Getting all that set up ahead of time. And then you get out of the tractor, right? You shut the cab door, and then you use your smartphone to control the vehicle from there. So you start Autonomy, and then the vehicle takes off and executes the plan that you established, whether that's spraying, avocados or whether that's tilling a field and gets back to you with operational based decisions.
Wow. So I'm going to be silly here. Basically, the farmer has the farm in the phone, and he can see the weather, see the boundaries, see all the various different aspects that he needs to operate his farm.
100%, right? It really is swipe to farm, right? Like you swipe and the vehicle goes and all the operational based decisions are now in the palm of your hand. Yep, that's right.
Swipe to farm. I like that.
So, along with that, the next common thing is, hey, what does that mean for connectivity, right? Obviously, if I'm swiping to farm, if I'm making, operational based decisions on my phone, that goes with saying that my tractor, right, needs to be communicating with me. I could do things like check live cameras to see how the job is progressing. So, I don't know, when you got your first cell phone, maybe it's the same for me, right? They showed you those coverage maps of the US. And I got my first cell phone a long time ago. I came from a rural area and I was always in the white spot, which meant I got terrible connectivity, right? And that was a lot of years ago. It's gotten better since then. Lots of people have moved towards more populated areas. That's actually been some of the driver of some of these labor challenges that we're talking about. But along with that, right, the coverage map has gotten better. That's not always the case for some of these rural farmers, right? They're still in some of these white areas, about 25% of these folks, right, where connectivity is a bit of a challenge. So with that, one thing that we've done this year is, well, maybe 2 things. One is continue to advocate for rural broadband. It's really important, right, in some of these areas. And the second is, hey, what non-terrestrial solutions can we use to bridge the gap? So this year, a lot of our tractors have gone to the field with what we call JD Link Boost or a Starlink enabled kit to enable that great connectivity, even if you're in the white spot on the map where maybe, the ground-based connectivity isn't very good.
Starlink, I read the press release, I think it was in Brazil, and you're seeing some of the early results that have been really positive. What type of bandwidth is the tractor having to set up? Are you sending small packets? Are you sending large packets? And are you running all the compute on the tractor, running in the cloud? How's that working?
Yeah, 100%. So all the compute is on the tractor. So for all of the solutions that we have today, so, from the some of the things we unveiled at CES were as small as like a commercial lawnmower up to the dump truck that you're a big fan of, right? Have 2 of these. So they have 2 Orin-based NVIDIA GPUs on board and 2 separate, hardened GPU enclosures that we make in-house. And all of the real-time decisions are made on board, right? Data that's sent off board, the primary customer and user of that data is the customer, right? To make great agronomic decisions, to monitor their machine via real-time image streaming. If we saw something in the field that we thought was interesting, we can tack that on their operations center map for them to look at later, right? If there's a rock you need to go back and pick up that we drove around, really handy to have a pin and a picture of it, right? So I know what rock I'm going after, things like that, right? Those are a lot of the reasons that we're sending data off board, in addition for any of these operational based decisions as well.
If you look at it, automation and connectivity are enabling the farms to scale, and they're enabling to put yummy food in our tummies, and we get yummy tummies. Deere's really been at the forefront of all this. You've really ushered in precision ag. Aaron, in your opinion, what is the future of precision ag and automation on farms?
It's a great question, right? Like, I like the forward-looking questions too, because those are always a lot of fun to think through. So, if I think about the automation journey that's gotten us to today, what have we done, right? Well, we've done things like auto track. We talked about that, GPS steering. We've talked about how to make the rows tighter and more consistent and productive, and look for things like job quality, right, to make sure we're doing a great job, and all the digital products that go with it. But largely, it's all been with this assumption that, hey, I'm making this easier for the individual in the cab, for sure, right? There's somebody there that's putting in a 10 to 16 hour workday, because that's the average workday of a farmer. Let's make that job easy for them, right? Let's make it easy and also make that operation really productive. And that has been automation up to this point. Where we're at today, I think this is the next chapter in how we feed the world, right? Is this autonomy transition where more autonomous solutions will be available for some of these pinch points in the production cycle. And I think automation that supports autonomy is going to be a really interesting problem, right? Because when I go out to the field, whether someone is running one of our autonomous machines or a manual machine, if they're in the seat, what I see them doing is they're looking over their shoulder every now and then, right? And my favorite question to ask the farmer is, what are you looking at? What's important to you? What's back there that you're concerned about? And from my standpoint, we started talking about John Deere, the man, going out, talking to farmers, coming back and looking at the technology available. I like to go back and look at the technology available and say, okay, today I'm providing you that same snapshot with a smartphone, right? Certainly you can see a live stream instead of looking over your shoulder, right? From the dinner table, you're looking at your phone while the tractor is working. That's a step in the right direction. How do I extract more insights though? Are there other things and other automation I could bring to give you, to cause you to pick up that phone less, to cause you to look over your shoulder less, right? To increase the confidence and quality of the job being done. So I think that's going to be really exciting as we sort of move, into some of the autonomy era of farming and where we go from there.
If you look at it from the farmer's perspective, autonomy is going to bring on the certainty, because all the cameras and all the sensors, they're going to get the data they need, and they're not going to have to stress out about what about this? It's all going to be there in the Deere app. And it's really fascinating. If we look, say, a decade out, farming will be completely different for the better, and really good stuff. We can get maybe potentially higher yields, but the best part is, I harp on it because it's very important, the farm can stay in the family. And that means a lot to millions of individuals around the world. Aaron, this has been fun. And as you and I both know, nothing runs like a Deere autonomously. With that statement said, as we look to wrap up this insightful autonomous conversation, what would you like our listeners to take away with them?
Yeah, sure. This has been a lot of fun. I think being able to show up to work every day, and talk about autonomy has to be the best job on the planet. So happy to share this time. I think a couple things to walk away from, right? Farming is a really hard job. And I think the closest lots of folks get to a farm is 30,000 feet out the window, right, as you sort of pass over some of these areas. And because of that, we're just really challenged to find people to fill some of these seats today. And that's really what we're thinking about from an autonomy perspective. Autonomy, it's not designed to replace an occupied tractor seat. It's designed to automate an empty one, right? It's designed to bring that automation to really enable and reduce some of these pain points that these customers are seeing today, to enable safe and reliable food supply from California, from the Midwest, and from other areas in the future.
Yeah, it says farming is hard. Autonomy makes it a little bit easier.
I like that.
Thank you. Today's tomorrow. Tomorrow is today. The future is Deere. Aaron, thank you so much for coming on SAE Tomorrow Today.
Thank you for having me. I really appreciate it.
Thank you for listening to SAE Tomorrow Today. Be sure to join us next week when we'll speak with the CEO of SAE, Jackie El Sayed. She'll share her vision for how collaboration, standards, and people will shape the future of mobility, and how SAE is helping industries transform to get there.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.